Hello to Encik Fairuz and my friends. We are from Group 6 Section 2. What we are here is for presenting our project with title Peat Soil Properties and its Problem in Parit Nipah Batu Pahat. So our group consists of 5 members and they are me, Chu Chun Hong, AF210098, Chung Ming Yang, AF210109, Keng Ting Yuan, AF210117, AQIL DANISH, AF210065.
So for the introduction, geotechnical survey, the checking of potential problem in any region. Examining or evaluating, determine soil properties in order to clarify the existing problem. Peat, a surface organic material with decomposed organic matter. For the study area, we choose Parit Raja Batu Pahat. The problem and the solution here are difficulties in construction, low shear strength, highest water content and compressibility, and also there is a chemical stabilization, which is lime and cement. Ethelbert limit test. Boundary between each state of the soil can be described by a test via Casagrande method and cone penetration bit test based on the water content, divided into solid, semi-solid, plastic and liquid states. Stages of Ethelbert limits, which are liquid limit LL, plastic limit PL, and shrinkage limit SL, can be determined. Plasticity index PI is generated by finding differences between liquid limit and plastic limit. For the particle size distribution, the first point is soil categorization. Next, coarse and fine grain. Impact, the tensile strength and compressive strength. Both grain can be tested via sieve analysis and hydrometer analysis. Soil water movement prediction. Permeability, measure of how easily a fluid can pass through a porous medium. Affects the rate of settlement of a saturated soil under load and also affected the stability and retaining structures.
Based on the site investigation from different authors, the moisture content is very high. We show the peat soil is too soft that causes the soil to easily separate. For specific gravity, the physical parameter shows that peat is a very soft soil that is dominated by water in its structure. With all the data obtained from the past site investigation report, only one researcher was able to determine the plastic limit. Also, there is no data for shrinkage limit, since the water content at which further loss of moisture will not cause a decrease in volume. It is concluded that the Ethelbert limit tests are not appropriate for peat soil. As the research soil sample is peat soil, it is hard to determine the particle size distribution as the particle size is too small and only one researcher was able to obtain the particle size distribution, which are 72.78% of silt and 27.22% of clay. Based on these three authors, the shear strength gap is 10, 9.9, 14 kilopascal respectively. Shear strength is the mechanical property that usually required in design. Because of the capacity of this material to retain high water content, it is generally weak in its natural state, but significant strength gain is achievable with consolidation. The permeability from the both authors are 1.49 and 2.41 respectively, which shows the low permeability of peat soil compared with fine and silty sand. The range for maximal dry density of peat soil is quite near, which are 4.9, 6.535, 6.9 as 10 to the power of -7 kg per cm cube respectively. Furthermore, the high average organic content shows the remains of plants and vegetative materials whose rate accumulation is faster than the decomposition rate. With the high moisture content, the compressibility of the soil is too high and unable to determine the compressibility value.
British Standard Classification System (BSCS) has been used in this research to classify the soil sample. By referring to the particle size distribution of the soil sample as shown in previous slide, we can know that it is a peat soil where it consists predominantly of plants remain such as fibrous or amorphous plants. Next, we continue with the correlation graph. The first correlation graph is the shear strength of the peat soil to the liquid limit of the soil. The equation found from the graph is sigma is equal to negative 0.012 times liquid limit plus 13.622. Next, this is the correlation graph of average organic content to the liquid limit of the peat soil. The correlation equation form is organic content is equals to 0.2301 times liquid limit plus 34.874. This is the correlation graph of average organic content to the moisture content of the peat soil in Parit Nipah. The correlation equation is equals to organic content equals 0.2036 times moisture content minus 9.1996.
This shows the graph of correlation between shear strength, sigma, and moisture content, MC. Next, for this graph, it shows the correlation between average organic content, OC, and moisture content, MC. And the last one is the graph of correlation between average organic content, OC, and average liquid limit, LL. Next, in conclusion, it is very important to do site investigation first in order to ensure the place is suitable for construction. If not, tests should be done to make sure the soil is fulfilling the standard form that was made by the researchers. This is to prevent the building from collapsing and can be used for long terms. Peat soil have various properties depending on its geographical location, and this will result in different engineering traits and behavior. Thus, research leading to a performance is needed. That is all from our group. Thank you for listening.